Hello, today we will talk about the difference between using real-time operating system and not using real-time operating system. Operating system means that you have a hardware and software. So you made your code and you have hardware to operate on, to test it on. And real-time means that it happens when you exactly want it to happen. Like anything related to missile system, you can't be in a war and click on fire and it doesn't fire. So it seems so funny for the enemy maybe. And in space, in anything related to humans life, so real-time operating system is so determined here, and it's too important to use it. No real-time operating system, yeah, you have your code, you have your hardware, but you don't have time management here. Means that if you want something to happen, you have some tolerance for the time you are using here. So how exactly this happen and this happen? In a normal code, you building your code, writing a function here, and this function ends going to another function, it ends going to another function, and once a function ends, it is removed from the stack, it is removed from the stack, it is removed from the stack. The context switch only occurs when an interrupt cuts a function like that from here. Then a context switch will save registers here and save a program counter and link register. And then when that interrupt occurs, it will go back to that function and keeps operating to it. But here I'm having multiple tasks. Task 1, task 2, task 3. Oh, real-time operating system is more likely that a data structure. It's a real data structure, so every task has its own stack. Every task has its own stack. Every task has its own stack. You make your task inside a while loop. So if you used here delay, it will block everything. Your processor will be blocked for some time. You did it here, not only in your function you are working on, not only in the function you are working on, but your processor will be completely turned off. That time it will never do anything, it will just be being blocked, your processor. Here, if you use delay, what will occur? First, use delay here. Maybe at that time, I don't know where in the code, but maybe the code was here. So it will do a context switching here, means that it will save the link register, it will save the program counter, it will save my registers here used for the data I'm operating on, and then it will block that task for that time. Then it will go for the second priority task, and it will occur here, then it will go here. Once this time is over, it will be back to that task again. So context switching here occurs between functions. When it leaves any function, it keeps the data of that function, as every function has its own stack. So I need to clear everything here, so I will pause it for some time. So how it really happens, every real-time operating system have something called kernel, and kernel keeps the priority of all tasks, and I'm specifying in my real-time operating system a tick. Each tick, the kernel go and check if the highest priority task is now operating. If any task is being blocked, it will block it. If any task is being unblocked, it will unblock it, as it has a more priority than the current running task. So if I'm in task 1 and it was blocked here, then After that tick comes, the kernel will go and check. Oh, task 1 is blocked. Okay, I will go to task 2 as it has a middle priority, nothing is blocking it, so it occurs correctly. And next tick it come. Maybe the reason which task 1 was blocked for is now gone, so task 1 need to be unblocked. So the kernel will check who has the highest priority here. Oh, task 1. Is it blocked? No, so go to hell. I'm going back to task 1. It will go back to it and then operating successfully. So the kernel here provides me maybe more functionality, more determinism, and as you can see, you can manage your time correctly. So what if I, okay, let's clear it. Okay, what if I have task 1 and nothing to block it? It will keep looping, 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 and it will never go to the second task. So if you want to have many tasks here, you should make sure that there is a blocking condition here, so it will go to the second task. As the highest priority task has no blocking condition, it will never go to the second task, so it should have delay or something. So you told me you have a while loop here, but I can't. What's the difference between while loop here and while loop here? While loop here, it will keep occurs periodically here. If you have a while one here, it will keep going on, going on, going on, as there is no condition ever for returning or break from it. But here, while loop will keeps going. Once it has a blocking condition here, it will block that function, it will do a context switching, then it will go to the second task. Once the blocking reason is gone, so it will go back to the first task. From where it was blocked, it will go back to that place. As I told you, I'm pushing the program counter into the stack of task 1. So once I'm getting back here, I'm getting the values, I saved them here. So I will have my program counter back, I will have everything back, and that will go and work fine. Once a blocking condition comes again, it will block and like that. Here, no, you don't have brakes, so it will never block. It will keep going here, and you can't ever get out as there's no condition to get out. So real-time rating system is providing a get out place, and you don't have to write it in your code. It just provides it in this APIs. So I hope I made it clear as possible. If you want to really know how it works there. And if you have any questions, feel free to ask them down here. Thank you.